The Arabic mathematicians indeed revised and reconstructed many fundamental ideas in mathematics, but they made lasting contributions. Abu Kamil, often called the Reckoner from Egypt, was the second of the great Arabic writers on algebra. Little is known of his life and activities other than that he is apparently of Egyptian descent and wrote in the period following Al-Khwarizmi. His book of algebra, a title commonly used by early Muslim algebraists, is essentially a commentary on and elaboration of Al-Khwarizmi's work. In part of that reason, and in part for its own merit, the book enjoyed widespread popularity in the Muslim world. A much more extensive treatise on algebra than that of Al-Khwarizmi. Abu Kamil's algebra contains a total of 69 problems, compared with the 40 of his famous predecessor. As would be expected with the commentary, Abu Kamil carried over intact many of the problems that Al-Khwarizmi had explained. At the same time, he did not hesitate to add further methods of solution to those presented by earlier author. This may be seen in problem 8 of the algebra. As expressed by Abu Kamil, it reads, divide 10 into two parts, in such a way that when each of the two parts is divided by the other, their sum will be 4 1/4. In modern notation, the problem consists of finding two numbers to satisfy the equation x plus y equals 10, x over y plus y over x equals 4 1/4. The algebraic identity x over y plus y over x equals x squared plus y squared over xy is used to convert the second of these to x squared plus y squared equals 4 1/4 xy. Abu Kamil first solves the problem along the lines of Al-Khwarizmi's, that is, he puts y equals 10 minus x into the previous equation to obtain a standard type of quadratic equation, namely 6 1/4 x squared plus 100 equals 62 and a half x. With solutions x equals 2, hence the corresponding value of y is 8. Abu Kamil then presents a method of solution of his own, one which involves the old Babylonian procedure of introducing a new unknown quantity z by letting x equals 5 minus z, y equals 5 plus z. When these values are substituted, the equation x squared plus y squared equals 4 1/4 xy becomes 50 plus 2z squared equals 4 1/4 times 25 minus z squared, which yields z squared equals y. This gives z equals 3, and in turn the numbers sought are x equals 5 minus 3, which is 2, and y equals 5 plus 3, which is 8. Abu Kamil developed a calculus of radicals that is quite distinctive. He managed the addition and subtraction of square roots without using our symbols by means of the equalities square root of a plus or minus square root of b equals the square root of a plus b plus minus 2 times the square root of ab. The introduction of irrational solutions for some quadratics is another point of departure from the foundation work of Al-Khwarizmi. Abu Kamil's algebra holds an especially important place in the development of mathematics in the West through its influence on the works of the Italian Leonardo of Pisa, better known as Fibonacci. Another prominent scholar in the early history of Arabic mathematics is Thabit ibn Qurra. He was a mathematician of diverse talents and accomplishments, distinguished physician, skilled translator, and a prolific writer of close to 150 book works. Sabit's gift with languages, resulting perhaps from his being a money changer in his youth, allowed him to prepare excellent translations of the bulk of the Greek mathematical works. Sabit's book on the determination of amicable numbers concerns the study of numbers as understood in the Pythagorean sense. It is usually regarded as the first completely original mathematics written in Arabic. The work contains 10 propositions, including one of the construction of amicable number pairs, that is, pairs of numbers, each of which is equal to the sum of the proper divisors of the other. Sabit's great contribution involves his remarkable rule regarding prime numbers and a pair of amicable numbers. Also with that, he also contributed by giving a generalization of the Pythagorean theorem that would apply to any triangle whatsoever, which is given right over here. Among Sabbath's mathematical writings is a book on the measurement of the conic section called Parabolic. In it, the determined area of a parabolic segment to be two-thirds the product of its base and height. A notable mathematician who was active at the end of the 10th century is Abu Bakr al-Karaji, or al-Karahi, as he is sometimes called. Little is known of the details of his life other than that he lived in Baghdad around the year 1000. Al-Karaji's major work titled Al-Fahri, or The Marvelous, is dedicated to a local ruler of that name. Its significance lies in being the earliest detailed account of the algebra of polynomials. Al-Karaji's included several results on binomial expansions, which led to development of Pascal's triangle. During the second half of the 11th century, an aggressive new power advanced into Persia. The Muslim Seljuk Turks seized Baghdad in the year 1055, ending the political domination of the caliphs over the eastern provinces under their empire. Under the narrowly orthodox Turks, Baghdad gradually withered away as an important intellectual center, but learning still flourished in the Western Caliphate, particularly in such cities as Cordova, Toledo, and Seville. One of the scholars to remain in Baghdad is more celebrated outside the Islamic world for his poetry than for his mathematical achievements. Umar al-Khayyam, better known as Omar Khayyam. The Rubaiyat, in which he praises the delights of the senses, has been offered in hundreds of editions. The most influential of his mathematical works in full title Treatise on Demonstrations of Problems of Algebra and Al-Muqabala considerably advanced the subject of algebra. Where Al-Khwarizmi dealt with linear and quadratic equations, Khayyam constructs the solutions of all kinds of cubics by the use of intersecting conic sections. The establishment of magnificent observatories, such as the one in Baghdad in 829, is the influx of great astronomical texts stimulated the interest of Arabic mathematicians in astronomy as well. Their skill in computation provided the accurate astronomical tables so necessary for orienting the mouse in the direction of Mecca. Khayyam was among those who made notable contributions to astronomy. He claimed to be the first mathematician to solve every type of cubic equation having a positive root. Since he did not recognize negative numbers as coefficients, he has made erroneous conclusions, but it did not take away his mastery of geometrical theory of third-degree equations, which may be regarded as the most successful accomplishment of an Arabic mathematician. A careful observation of the heavens was a major focus of Islamic mathematical activity, partly out of genuine scientific interest, but mainly to regulate religious practices. Caliph al-Ma'mun, who had a personal interest in science, set up an observatory in Damascus and Baghdad, with al-Khwarizmi and Ibn Qura spending their time there. Al-Ma'mun's astronomers revised the astronomical tables in the Amalgast by taking simultaneous observations in Damascus and Baghdad. Their own tables ultimately replaced those of Ptolemy. Over the next few centuries, Arabic astronomical activity underwent periods of decline and revival due to religious authorities. The mathematician and astronomer Nasir al-Din al-Tusi flourished during the mid-13th century in one of the most tumultuous periods of Islamic history. He has fled, betrayed, and joined multiple parties to survive during Genghis Khan's rule. He then served as an advisor to Hulagu Khan, one of Genghis' grandsons. Although Al-Tusi is best known for his numerous astronomical works, he was a scholar of exceptionally wide learning who tried his hand at many things. He composed a variety of treatises on such subjects as logic, philosophy, ethics, arithmetic, and trigonometry. He brought out greatly improved translations of Euclid's Elements, Apollonius Conics, and Ptolemy's Almagest. Hulagu Khan and his grandchildren, Tamerlane, and great-grandchildren, Ulugh sponsored many observatories over the years. Persian mathematician Ghiyas al-Din al-Kashi was brought to Samarkand to take charge of the new observatory, where he expanded it to an institute of learning. He was focused on making more precise measurements and tables. Al-Kashi's treatise on the circumference expounded on the use of decimal fractions. His representation of pi is as correct to 16 decimal places, greatly exceeding all previous calculations, and remained so until the 16th century. Al-Kashi was also the author of the Key to Arithmetic, treatise on the chord and sign, the calculator's key, as well as several works arising from his astronomical research. After the 13th century, scientific inquiry, in general, began to wane throughout the Arabic world. Current scholarly thought was more engaged in religious, philosophical, or legal studies. Their advocates had become suspicious of foreign sciences, whose contributions they deemed to be useless in Islamic culture. Ulugh was assassinated in 1449, and with his death, scientific pursuit lost its last great defender, as observatories and personnel and scholars fleeing for their lives.